Hey guys, welcome to my first YouTube video. And okay, you might definitely be wondering why is this guy that I've seen on X is making YouTube videos all of a sudden. Honestly speaking, even I'm quite curious about it as to how the hell am I here. But honestly speaking, if you have read my blogs, you know that I try to write as much as possible about the projects that I'm building because I feel that the the more you can educate someone else on a project that you're building, the greater your own understanding of the project will be. So here I am. Currently, I'm all in on a project called Styx, which is me building a BitTorrent client from scratch in Rust. So if you'll come over to the comments and see that I've been hard at work on this entire project. But BitTorrent is a software that is so deceptive in its simplicity because you might feel that okay, I clicked the .torrent link and the client open and it's downloading, and as if that is everything there is to it. But it's not. BitTorrent is a massive behemoth of a software with a lot of components, a lot of very interesting deep components that have to fit together in a very nice way, like a Lego building or something, for the BitTorrent client to work. So its architecture is very interesting actually. And I'm in this first video, we are going to discuss the most obvious thing. So I guess every one of us has felt this question in our childhood. Let's say, like, if you remember back in the day, for any Gen Z, for any 2005 bonds or 2004 bonds out there, you might remember that Halo CE was a very popular game. Maybe not so much in India, but internationally, it was a booming success. That was the game that kickstarted Xbox. So, naturally, a lot of people who were not as fortunate enough to be able to have access to the consoles and games wanted to still play the game. So, where do they go? Lo and behold, our only savior is the torrent websites back in the day: Pirate Bay, Cat Torrents, etc. etc. But how do you think a torrent client works? So this is me. I want to play Halo. I come to a totally legit site, obviously. Who said Pirate Bay is not legit? Anyway, not implying anything. You click download and it downloads, and I think this is a very common situation that we have faced, is the fact that a lot of times your download would be stuck at 99% for a very long time as a kid, and it was the most frustrating thing in the world because I just want to play this game. I don't want my parents to know that I'm downloading a game on the family computer, and the fact that I'm doing it overnight so that when I wake up next day I can come back from school and play the game. But this bitch is just stuck at 99% and it's not downloading fully. So it's a very relatable struggle. We have all been there. But why do you think this happens? What is so fundamentally different about a torrent file as compared to a .exe install that it gets stuck at 99%? Well, the answer lies in this figure, or part of the answer, so to speak. So let's assume there's a 4 MB torrent file. Well, as opposed to, let's say, if I'm able to use something here to demonstrate, let's just say this is a server. It's not, it's a database icon, but let's just say this is a server, and what you might expect is that there is one server which gives you the file and you download it from there, but that is not the case. That is totally not the case with wait, that should be read actually. That is totally not the case with how torrents work. A torrent file is actually chopped up into many pieces and distributed to people. So it's not coming from a single source. It's coming from multiple sources. So let's say when I'm trying to download my precious games, that one game has been chopped up into, let's say, 1,000 pieces, and 1,000 people have those 1,000 pieces. And a torrent file is kind of greedy in a sense compared to a single server source, in a way that it will try to grab any piece from anywhere it can get. It doesn't give a shit if it's coming in an order or not. The order part is the order aspect of this is a different topic altogether, which we'll discuss further in the video. But for now, you have to understand that it's trying to get everything at once from whichever place it can source it from. So in a single server, piece 2 will come before piece 3. In a torrent based file, that will be the case, but it is not necessary that it will be fetched in the same way. It depends. It's quite complicated. I know it must be complicated, but for now, bear with me. So let's say there's a 4 MB torrent file I want to download. It has 6 pieces. Now Adi has piece 1 and 2, Samarth has piece 3 and 5, Harsh has piece 1 and 4, and Sarthak has piece 6. But not a single person has all the 6 pieces. So this is what you call a swarm. The people who have the pieces are known as seeders. People with pieces are called seeders. And people who don't have pieces, or people who are downloading, are called leechers. How that's clear? It's just torrent lingo. You are free to understand it in any simplistic way you wanna, but this is the terminology that we will be using for the rest of the video. So all of these guys are seeders since they have some piece of the main file. Well, so now the question comes, which you definitely must have in your mind, is, Atos, how do we decide which piece we should pick up first? Since not a single person has all the pieces and we are trying to complete the download as fast as possible, how do we make sure that we pick up the correct piece and in the correct order? Piece 1, Adi has piece 1 and piece 2, so he's the seeder of piece 1 and piece 2. Only Sarthak seems to have piece 6 and no one has piece 6. So, like, what should we do? This is a very valid question. So, let me demonstrate it with a simple diagram. Let's say this is a piece. I'm using circles to denote the number of seeders, so hope you can understand. And let's say this is 1, and let's say this is piece 40. Yeah, this is piece 40, and this is this is piece 23. Let's say it's piece 23, and let's say this is assuming this is 100 seeders, and this has only 2 seeders. Let me enlarge this a bit and make this white here. So who do you think we should pick first? Now this is a very crucial question. Imagine your download is stuck at 40%. Which piece are you going to pick? You're faced with a choice, and you have to pick either piece 40, which has 100 seeders, or piece 23, which has 2 seeders. Well, general opinion, following general opinion, a lot of people will say that obviously I'm going to go for PS40 because it has the most number of people. Well, the problem with that kind of behavior is that not only you have that idea, the rest of the 1,000 people in the swarm have the same idea. So everyone is running towards PS40 and not a single person is going towards PS23. So PS40 is overcrowded with people and PS23 has no people. And let's just say, in a very realistic scenario, that the two seeders who were supplying PS23 log off their PC and go to sleep. Now PS23 is not in the swarm only. In the entire swarm, there is no PS23. So, well, everyone got PS40, sure, but no one got PS23. And the download will then be stuck. So, you got PS40, no one got PS23, sure. The download goes on, it goes on, it goes on. It reaches 99%, 99.99%. Forgive the abysmal handwriting. It will reach 99.99%, and then everyone will realize that, oh shit, we don't have PS23 because the people who are supplying PS23 aren't online. And that is when you get this download stuck issue that we discussed here. So this approach, I think we can, safely speaking, we can call this approach as something, whatever, like most common piece first type shit, I guess. Well, now you saw whatever the entire clusterfuck happens when you choose the most common piece, the one with the most seeders. So the question is, Atos, how do you fix this? How does anyone fix this? Well, our first approach was to go for the most common piece first. The natural instinct to that is, well, what if we flip our approach? What if we go for the rarest piece first? So this is what happens when you go for the rarest piece first. Now forget about this for a while. Let's imagine a classroom, right? Imagine a classroom. There's a kid named Adi, and he's the weakest kid in the class. Absolute weakest kid in the class. The teacher says, everyone go help the neediest kid in the classroom. Now, currently, the neediest kid in the classroom is Adi. So, the entire class has that same information. The entire class except Adi knows that the weakest kid is Adi. So, everyone rushes in to help Adi. Now, Adi goes from having no support. Adi goes from having no support to having immense support all of a sudden. This is meant to be a graph. So in a fraction of time, basically, Adi, who had zero support, now has everyone's support. But remember the teacher's instructions. Help the neediest kid first. Well, now that Adi is so well supported, there's a new neediest kid in town. Let's say Sarthak. Now Sarthak has zero support. So everyone will rush to help Sarthak. Now once that Sarthak is well supported, maybe a kid named Vansh becomes the neediest guy. So everyone rushes to help Vansh. So do you see the problem? This is like relocating the problem. It's not fixing the issue, it's relocating the issue. There will always be a new neediest kid, and the problem is that once that first everyone went to help Adi, now Sarthak was under the risk of getting lost, because when you chase the neediest kid first, what happens to the kid who was the second neediest? So let's say Adi was the most neediest kid, then came Sarthak, then came Vansh, maybe, let's say. So when everyone went to help Adi, Sarthak had no help anymore. Sarthak, who maybe had the support of few people at least, now has support of no one because everyone went to help Adi. because everyone is instructed that they should help the neediest kid first. And now let's say eventually Sarthak has everyone's support. Now Vansh has no one's support because everyone left to help Sarthak. So this is what is happening in torrent terms. Let's say that at t equal to 0, piece 395 is the rarest piece in the swarm, to be correlated with the neediest kid in the classroom. By t equal to 10, everyone in the swarm has rushed in to download piece 395. Now piece 395 is healthy. It has 20 seeders. It has helpers. It has people like Adi did. But now this is piece 521 has taken the place of Sarthak in a sense of speaking. Piece 521 is the rarest now. Now everyone rushes to help piece 521. Now piece 521 is healthy, but now piece 634 is left behind. So the problem keeps jumping through hoops. It's not fixing the problem in a sense. The algorithm eats his own tail. I've written this statement here for a reason. Because the problem is this is the loop that the algo is following. And the problem just keeps shifting. Well, but how did our beloved torrent clients like BitTorrent, uTorrent, QBitTorrent, how did these guys fix this issue? Because no one can deny the absolute efficiency of this algorithm that is rarest first. Well, what they did was that once they reached a position where they would be stuck at 99%, they used to check. So when they had a tie, when they had a stall, they used to check which is the new rarest piece, and then they will go for that person. So for example, everything is going good, everything is downloaded, we are at 99%, we are stalled. So it will check against many people, how many seeders does this piece have, yada yada yada, and whichever is the rarest piece, they will rush to help them. But then you'll say that this tiebreaker strategy worked, right? Like, they are the most famous torrent clients for a reason. No one has had any problems per se. Well, you would be true in saying that, but it's not it's not correct because it's correct by principle. It's correct because the torrents that you're downloading are too healthy to expose the vulnerability. When you don't have an abundance of seeders, you will feel the problem there is with this strategy that they're using for breaking the tie when they get stalled at 99%. But when you have 500 seeders at hand every single second, which usually happens for the most famous of series and games, you will never feel this issue because you'll always have people to chase. So when I was building my client, I thought, how could I fix this? What can I use to, fix this by principle or fix this by construction? Well, now you must be thinking, well, Atos, but we have had beloved torrent clients for a greater part of a decade, even more than a decade. uTorrent, BitTorrent, QBitTorrent, I'm sure you all know the names. How did they work? If rarest-first has this issue inbuilt in it by principle, how did they how did they solve this issue? So let's go back to that first diagram, 99% stall. Well, these guys had a different approach to fixing this issue. They said that whenever we would be tied, so let's say at 99%, you have four pieces and all four of them have two seeders. Now, how do you choose which piece to chase? The rarest first won't apply here because four pieces have two seeders, and that's the minimum number of seeders remaining. Like, your download is almost done. These are the only pieces remaining, and every single one of them has two seeders. So how do you chase it? So they did randomization. Upon stall, they will randomly select one piece and they'll go after it. This is randomization, which is fine because you will never notice this problem in a big or in a big torrent file or a torrent file with a lot of seeders. So any famous movie, TV show, game which has a lot of people seeding it constantly, you'll never notice this issue to begin with, but you will feel the problem that this randomization based tie breaking brings when barely 10 people are seeding the whole thing. So I thought when I was building this, when I was building Styx, I thought, how can I be different in this aspect? How can we try to fix it? Right. So I came up with something called RFWPMS, which I admit is a terrible abbreviation, but it expands to rarest first with probabilistic mode suppression. It is jargon for basically let's go back to the classroom analogy that we had. So when the teacher said, go help the neediest kid first, add an asterisk to that. So I'll write it here. Help the neediest kid first, asterisk. Asterisk being randomly help the second and third neediest kid as well. So going back to our three people, Adi, Sarthak and Vansh. So in this approach, or in the approach of the old guard, the famous approach basically, was that the entire class rushed to help Adi. And Sarthak fell behind. But when Sarthak fell behind, everyone rushed to help Sarthak. Now Vansh fell behind. So we discussed this already. So by the new rule, everyone will go to help Adi, but some people will go to help Sarthak also. So now so as like if you say this is a chart, oh wait, if this is a graph, if earlier Adi had immense support all of a sudden and Sarthak had no support because everyone was helping Adi, let's say this is Sarthak, Sarthak has no support. The new approach is saying, wait, the new approach says, what if we did it in a way that Adi has a lot of support, but a few people also go to help Sarthak. So now both are in a relatively healthier position compared to the rarest first approach. This is entire crux of RFWPMS, or rarest first with probabilistic mode suppression, that definitely go help the rarest piece first. The raw efficiency it brings to the table is unquestionable and it is the best approach. But instead of relying on a tiebreaker, on a probabilistic based tiebreaker, better to probabilistically chase pieces which are second or third rarest, which brings us to this relatively healthier outcome of this algo. But obviously you can't rely on my word for it. Why should you? So and even I couldn't. It was a novel approach of sorts, but also of course I had to test it. So what I did was make a fake swarm. I made a fake swarm, and basically I'm using a demonstration of 5 peers here. I obviously had a lot of peers in my swarm, but I made a like imagine there are 5 seeders. Now every seeder has a different personality, right? Some people are chronically online, so they'll be seeding that piece constantly 24/7. Some people are almost never online, so the chances of them seeding that piece is so low. So I emulated 5 personalities. Two people who have slow internet connection. One person was a slow internet connection. One person was fast. One person who leaves at a certain time. One person whose net is so bad that he drops every third uh, time click, and someone who has a very good internet and they stay online forever. And I made this tick for 1,000 seconds. I made these in a sense of illustrations. Basically, I made these 5 peers work for 1,000 ticks, and I tracked everything: peer session, request, block events, seeder events, and piece snapshots. and I came up with this chart. So the red line is the approach of the old guard, which is the rarest first algo, and the green is my approach, the probabilistic mode suppression. On the y-axis is pieces lost from the swarm, and the x-axis denotes the time. So you'll see that in my approach, lesser pieces were lost because of the thing we discussed here. These guys do a probabilistic tie breaking, right? Or even if you don't include that, for simplicity's sake, rarest first was losing pieces. Sarthak was lost when Adi was the one being chased, and Vansh was lost when Sarthak was the one being chased. Piece 521 got lost. Piece 634 Cedars left. It's Cedars left, so it's akin to being lost. So in my approach, a considerable number of less Cedars, a considerable number of less pieces were lost. And that was the result I arrived at eventually, that okay, this thing works, this approach has substance behind it. So that was that. That was the entire title, that I didn't understand BitTorrent, so I simulated it first. This is what I did in my simulation of the fake swarm and why it matters. Hope all of you understood it in some capacity. This is my first video. I've tried my best to explain in a very simple manner. Please let me know if you have any questions and suggestions, anything, just let me know in the comments. You can find me on X and you can find me on X at @dios_, and that's it. See you guys for the next video. I'll come back with a newer topic. I'll try to keep up with the blogs as well. The last blog I wrote was about a Ben code parser, and that will be the topic of the next video as well. So yeah, see you guys around in the next one.